Hi, it's our third and final round through sequences. If you remember, we did sequences in Chapter 1, talked about explicit and recursive formulas. So we did arithmetic sequences where you always get from one term to the next by adding or subtracting, which is the same as adding a negative. And we had a constant difference we called d. In this section now, we're going to have a constant ratio. So for geometric sequences, you could say for those, you get from one term, which is just one number in the sequence, to the next by multiplying. And before, when we had the arithmetic sequences, we talked about how it was either adding or adding a negative with subtracting. In this case, you could multiply by a fraction, which then would be the same as, you could say, or dividing. So maybe just toss a couple examples down. So a couple examples, one would be something like if you had the sequence 1, 4, 16, 64, ... That and that one we're multiplying by 4 every time. Or you could, if you wanted to, have something like 100, 50, 25, 12.5. Now for both of those, well, so this one here, so it looks like you're dividing by 2 each time. So in this top one, you're multiplying by 4, multiplying by 4. This one here, you're dividing by 2, which is the same as multiplying by 1/2. So multiplying by 1/2. And the reason I write that in there is that now we're going to have R is going to be our constant ratio. And if you think of what a ratio is when you divide numbers. So a constant ratio then is going to be when you have some number divided by the number in front of it. So take any number in the sequence, divide it by the number in front. So 50 divided by 100 gives you 1/2, what you're multiplying by. 25 divided by 50 gives you 1/2, what you're multiplying by. 16 divided by 4 gives you 4, what you multiplied by. So that's going to be your constant ratio, and that'll be for all geometric sequences. Also, we should write out what the two formulas are. So now if we have the explicit formulas, those are all going to look like this. So g sub n, at least if it's in the right form, g sub n is going to be the first term times the constant ratio to the n minus 1 power. When we write it just as a formula, as an equation, we don't need to have parentheses around our exponent there. But when you punch it into your calculator, you do, unless you're going to do that exponent in your head. So write the parentheses in, don't write them in, it's up to you. We'll squeeze the recursive formula over here. So recursive formula. And if you think back to what a recursive formula is, that's going to be where you're dividing, trying to do things at once. A recursive formula, that's going to be where you're given the first term, and then from there it tells you how to find a term from the term before it. So recursive formula, then we're doing g's here for geometric. G sub 1 equals, and you have to fill in what that number is. And then g sub n, the nth term, is the one before it. So g sub n minus 1. And now not a subscript anymore, times r. And if you're really doing it right, you'd put in a comma and then say for n is greater than or equal to 2. So that for this bottom line, it only works to find the second term, the third term, the fourth term, and so on. Since we've done sequences twice before in my class, I'm just going to do 3 examples and then we're done. If you're rusty, you could go back and look at the notes from Chapter 3, probably be your best bet, perhaps Chapter 1. You're going to find a lot of similarities there. So my first example here, find the first 4 terms given by, we'll put down an explicit formula. So we'll say first 4 terms given g sub n equals 4 times 2 to the n minus 1 power. And there's a couple ways you could do that. One way is to go through and say, well, I'm looking for the first 4 terms. This isn't necessarily the smartest way, but it's probably the most surefire way to do it. So you could say, well, this first term, that's going to be g sub 1. And now when we look at our formula, so g sub 1 n, like always, is the term number. So we have 4 times 2 to the 1 minus 1 power. And if you remember, we said you need to do that first. So 1 minus 1 is going to be 0. 2 to the 0 is 1. So we get 4 times 1. So my first term then is just going to be a 4. The second term then is g sub 2. So now n is going to be a 2, so we have a 2 minus 1, that becomes 4 times 2 to the first, which gives me 8. So you could go through for each of them, put in a 3, put in a 4, and so on, and you'd find that then you'd get a 16 and a 32. What's going to be a little bit shorter is to go through, and let me erase a little bit of this here a sec. It's going to be a little shorter, is if you notice that this is in the form of the explicit formula that we just wrote out. So you have g sub n equals g sub 1 times r to the n minus 1. And they're not all this way, but most of the time they are. Then once you see that, you can say, hey, well, hey, my first term has to be a 4, and my multiplier, my constant ratio, is 2. So you have 4 for your first term, times 2 gives you 8, times 2 gives you 16, times 2 gives you 32. If you think back to the shortcut we had in the graphing calculators, you could do 4, enter, and then when you type in times 2, as soon as you do this multiplication, it'll automatically put the little ANS in front, or you could do second negative to do it. I'm talking about Texas Instruments calculators. And now every time you hit enter, it's just going to give you the next term. So that'd save you some time if you're doing it that way. That's two ways to get this first example. Second example, we'll do the same thing, but this time we'll have a recursive formula. So copied one down here. So find the first 4 terms given g sub 1 equals 48. And we'll say the nth term equals the term before it. That n minus 1 should all be in the subscript. Now out of the subscript, we'll say times 1/2, and it should be 4, n is greater than or equal to 2. Now when we're looking for the first 4 terms, the most common mistake people make here is that they forget the 48. They write down 24 for their first number. But the first term, g sub 1, is going to be this thing here. Well, the equation just tells us, hey look, g sub 1, it's 48. So that's 48. Then to find each term, take the 1 before it and multiply by 1/2. So we have 24, then we'd have 12, and then we'd have 6, and so on. And again, you could use your calculator if it's a tougher math thing. You do 48 enter times 0.5 enter, 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 and it'll give you those for you. For the last example for the notes, I want to do that same thing backwards. So here's a sequence, 2, 6, 18, 54, and we want to write the explicit and the recursive formulas for that sequence. So we'll start out with the explicit. So like always, I'm going to ask you to know the equation from memory going into the test. So between that and it just makes it more likely to get it right, I encourage you to first write out the formula. So the nth term, g sub n, equals the first term, g sub 1, times r to the n minus 1. And now all we do, like normal, is we fill in how you're getting from one number to the next. It's r in this case, and the first term. So g sub n equals g sub 1, so that'd be my 2, times r. So if you're not sure, this one most people probably look at it and it jumps out at you, but we said r is going to be the nth term, pick any number, divide it by the number in front of it. So we could just do 6 divided by 2 gives us a 3. If you didn't look at that, most people probably looked at it and just said, I'm multiplying by 3. Then you have to the n minus 1 power. And when you get questions that say, is it a geometric sequence or not, that's what you could do, is take each term divided by the one before and see do you get the same constant ratio for each one. Alright, the very last thing, we have our recursive formula. Well, that one we had 2 things to fill in. We filled in what the first term was, then we had g sub n equals g sub 1, or I'm sorry, g sub n equals g sub n minus 1. Each term is a previous term times r. And then, alright, so now we do the same exact 2 things, really. You say, well, what's the first term? It's a 2. Put that in, and then put in what the multiplier is. So g sub n equals g sub n minus 1. Make sure that's a subscript. And now we're multiplying by 3. And by now you're probably pretty comfortable with sequences, and that's pretty much it for this section. Hope it makes sense.